Hi, everyone. We're happy and excited to be here with you and to present Atforestry, machine learning to protect our planet's forests. Atforestry is a story about using the power of AI for a good cause and how a special team has made this happen. It started as the brainchild of Martin, who wanted to use machine learning to analyze an extremely important environmental issue, deforestation. And it has continued with forming that forestry work group, a multidisciplinary team with Martin's data science background, Borja's technology expertise, and Yoni's math and business thinking. Although we came with different levels of experience, we immediately had an excellent team chemistry. Martin, please take it from here.
Thank you, Johnny. Well, just to give you some context in here, I think all of you should know that global warming is an issue. This is an environmental problem that we need to resolve right now. But why is this so important? I don't think that we need to explain these images, right? I think it's quite clear for all of us. What I would like to tell you is that by 2021, we had increased 1.2 Celsius degrees of the planet temperature. And to give you even more context, the Paris Agreement targeted the policies to reduce this impact to 1.5 Celsius degrees. However, with the current policies that we have in place, the expected scenario is that we will get a 2.7 Celsius increase by the end of the century, which is not good for future generations. So what can be done? There are some tools and mechanisms that have been put in place, and one of them is reforestation. But do you know why? Basically, forests sequester CO2 from the atmosphere. So the more forests that we have, the more will be the amount of CO2 that we remove from the atmosphere. But there is a problem when trying to run reforestation projects. And that is the monitoring component, which is very hard. And it is very hard because it is a manual process where auditors need to actually physically inspect these monitored areas, and therefore they need to consume a lot of time and resources. So what can we do? With Atforestry, we plan to contribute. Our solution automates the monitoring process using artificial intelligence and scaling up the coverage areas by using satellite images provided by the Planet Institute. Also, you can actually monitor deforestation from any device connected to the internet. Let's see how it works. Atforestry is relying on two core processes. The first one is a computer vision model, a convolutional neural network, which predicts the type of coverland which is seen from the space. The second one is a deforestation detector, which compares the output of the computer vision model at two different points in times. If the inference of the model results in a deforestation category, like for example, mines, agriculture, or habitation, we will signal a deforestation case. For training this model, we use an already labeled dataset provided by a joint competition that was run between Planet Institute and Keiko. The images came using a GOT format, and therefore we had to transform them before we could feed them into our models. This data was collected between January 2016 to February 2017, and they were covering the entire Amazon basin. Now, I would like to hand it over to my friend Johnny to dive into our value model. Johnny, back to you.
Thanks, Martin. So we heard what is happening on planet Earth, the pain in monitoring the situation, and our solution. Now let's talk about adding value. Money. We all like to talk about money. So we start with monetary value creation. Carbon credit markets are exploding. A market that approximately 3 years ago was $300 million is expected to reach $100 billion by the end of the decade. 100 billion. And as anyone who ever traded assets know, information gives market players an edge. We can monetize on that. We also know that governments need to constantly monitor the forests, and the automation of this process saves time and effort. We can monetize on that too. But business should not be just about P&L statement. We believe that business should also be about environmental and social responsibility. Forestry creates great intangible value by helping governments to audit reforestation projects and by helping NGOs to monitor deforestation. Atforestry helps our planet to keep the greenhouse effect under control and stay a healthy environment. Money again. Here is a quick glimpse of how carbon credit markets behave. Almost tenfold price jump in 1 year. Demand is a lot higher than the supply. And there's a lot of money to be made in carbon credit markets trading. Before the technical deep dive to our MVP, we'd like to briefly describe our journey as a team. Borja, Martin, and I have made the road from notebook to a fully functional end-to-end MVP in just little less than 18 days. And this was our first time ever with MLOps. On May 23rd, Borja and I joined forces with Martin, who had a lot of knowledge about environmental issues. It took us 2 to 3 days of team discussions to get into action. 2 weeks later, total of 18 days from May 23rd, the triangle working out of Barcelona, Bogota, and Tel Aviv had a full stack MVP up and running. It was really exciting to go to www.atforestry.com and click on the jungle map to get deforestation analysis. Team experience, it's worth it all. We can now proceed to the MVP and you can all click the link. Borja, please show us some magic.
Of course, thank you, Johnny. And the end result is this. This is the URL of our MVP. It's a fully functional MVP, and I invite you to try by yourself right now if you want to go there. Let me show you how it works. So I have it right here. So this is the area we're covering right now. It's 380 square kilometers. Just for your info, just to cover this, we need 10 gigabytes of data to cover this area. And this is like, I don't know, like 200,000, the fraction of the total Earth. If I zoom out, you will see more or less where we are, what we're covering right now. And if I zoom in, the user, you can go here and click on any specific area here, for example, right here. And you're gonna see here 2 moments in time, the zoom in, the detail of that area. And you can see definitely there's been deforestation here. And actually the model is telling us which kind of deforestation. We're just calculating deforestation right now. I can click in another area and so on. And for example, here there's no deforestation, and I could go on and go on. All right, so this is what we're doing here. We're covering this area. Let me go back to the presentation. And well, in our case, the architecture consists on 2 main elements: a test environment implemented in Kubeflow for data scientists to experiment with new models, and then an app stack based on Kubernetes. So let me explain you some of the key parts of the architecture. The most important part is fetch data. Fetch data every month is called by batch run, another microservice that makes fetch data to start the process. First, it searches the list available data on Planet API and downloads the geotiffs. Then it converts them to PNGs and runs the predictions for each one of them. Finally, it stores the predictions in our Postgres database, and the PNGs are stored in a Google Cloud Storage. Our plan was to serve the model from Kubeflow, but after a lot of effort to integrate Kubeflow with a VM with GPUs, we decided to serve it from Google Cloud Storage, and we use DVC as a version manager. That's the current MVP. Finally, the front end and showing the predictions. Every time you click on the website is developed with Vue.js and is running on a Docker image based on Nginx. A latitude and longitude is sent to the API. The API queries the database and calculates the deforestation based on the last 2 predictions in time. The images are pulled from Google Cloud Storage to be used by the front. Just lastly, as for the MVP, in order to develop faster and complete the MVP in 18 weeks, we implemented 3 special repositories that I wanted to share with you. The first one is the infrastructure repository. It allows us to implement infrastructure as code in order to spin up all we need with a simple shell command. The second one is a local start repository that allows any developer to start in this local machine all the microservices, again, with a simple shell command. And finally, the boilerplate template. This accelerates the development of new microservices with most of the DevOps staff is already factored in, like Dockerization, local execution, fast API implementation, everything is ready for developers to start working. Well, that's all from MVP side. I hope you find it interesting. Well, let's talk now about what's to come. All yours, Yoni.
Thanks, Borja. Now that we've seen the MVP demo in action, let's see, where do we go from here? First, we need to get continuous training in place, get more data resources. We need to have consistent and updated satellite image stream, and keep testing how new computer vision models to improve the deployed model. Next, we need to get a great commercial grade UI, improve cloud resources, and get cybersecurity in place. And then a major leap is to proceed with sales and marketing. Now, if we were on a normal startup, I would probably present now the unicorn Excel sheet and recommend that you'll consider this unique opportunity to jump on the train and reach out to your checkbooks. But Atforestry is a different case. We have created this project to give our planet a small present. So Atforestry's success can probably be measured by two main KPIs. One, the use and further community development of the project, how popular this service will be. And two, inspiring future projects to look at the same direction. And here we come to the end of the Atforestry presentation. Watching the credit box, we would like to give special thanks to the FourthBrain team, Super Greg, Magic Mark, and Amazing Ali. In the past 18 days, our team had a lot of fun working together. I'm smiling because it was really a lot of fun. And we hope that today you enjoyed listening. Thanks.
Thank you.